Hi everyone. Today we're going to look at what some of these area and volume questions might look like on the AP exam. So what they tend to do is kind of put these ideas together. You might also see some things like related rates come into play here, and you'll see that tomorrow in the practice. But I'm just going to run through one of these questions. This one happens to be no calculator, so we're going to go through it without a calculator. So the other thing I wanted to mention was I'm not going to be using colors anymore. While I think they're helpful while we're learning this, unfortunately on the AP exam they don't allow you to have colors, so I kind of want to move away from that now as we're practicing. So here we go. It says let R be the region bounded by the x-axis, the graph of y equals the square root of x, and the line x equals 4. So the first thing I'm going to do is sketch this in. Let's see. So I've got square root of x, which I know looks like this. The x-axis and the line x equals 4. Okay, so this is my region R right here. So the first question asks me just to find the area of region R. So this is just the area between two curves. So since this has a clear top and bottom, I'm going to integrate with respect to x. So I'm going to do top minus bottom here. So in this case, my top is the square root of x. The bottom is this y equals 0, the x-axis. So that's just the square root of x. So now I'm going to take the integral. My bounds are from 0 to 4 of the square root of x dx. Now, we've been doing a lot of calculator work, so it's probably good to go back and revisit what we have to do to evaluate the integral. So the first thing I need to do is I need to take the antiderivative. Since this is x to the 1/2, I need to add 1 to 1/2, so I get x to the 3/2. And then I'm going to divide by 3/2, which is the same as multiplying by 2/3. I'm going to add my plus c, and I'm going to evaluate from 0 to 4. So that's going to give me 2/3 times 4 to the 3/2 plus c. I'm going to subtract. Well, as soon as I plug in 0, that's just going to be 0 plus c. So now my c's cancel. Now, when I'm evaluating this, the first thing I'm going to do is take the square root. So the square root of 4 is 2. 2 cubed is 8, so then I get my answer is 16/3. So nice basic area problem. Now, part B is a little bit of a twist. We haven't really seen anything like this. It says find the value of h such that the vertical line x equals h divides the region R into two regions of equal area. So what they're asking us is to think about some arbitrary line x equals h. So I could just sketch something in here. And they want to know what that value of h would be that divides that area into two equal areas. So I'm going to consider just the area from here to h. So in other words, my integral, instead of being 0 to 4, is going to be from 0 to h. And I still have square root of x dx. So now what I'm saying is if I took the area from 0 to h, now I know that has to be equal to half of my total area. So if my total area was 16/3, this needs to be equal to 8/3. That ensures that that area is half my original area. So I've divided it into two equal areas. So now we need to do some work to solve. So I'm just going to focus here for right now. I'm going to ignore my 8/3. So I know my antiderivative here is going to be 2/3 x to the 3/2 plus c, and now I'm evaluating from 0 to h. So here I'm going to plug in h. I have 2/3 h to the 3/2 plus c, and then I'm going to subtract 0 plus c. So my c's cancel. So now really what I have is 2/3 h to the 3/2 equals 8/3, and I need to solve this equation to find my value of h. So the first thing I'm going to do is get rid of this fraction. And actually, luckily, this is going to work out pretty nicely for us. So my 3's cancel. 8 divided by 2 is going to give me 4. So now to finish this, I'm going to raise this to the 2/3 power, because when I multiply those, I just get the first power, and to the 2/3 power. So now h, I don't have a real nice way of simplifying this because I can't evenly take the cube root of 4. So this one I'm just going to write as the cube root of 4 squared, or 16. So there's the equation of my vertical line. That would divide that into 2 equal areas. This is actually something they like to do a lot, so maybe put a star by that so you have it for reference later. All right, next piece is a volume question. So find the volume of the solid generated when R is revolved about the x-axis. Okay, so just so I can take a look at this again, I'm going to draw my curve here. Oops. All right, so now this is my region. I'm going about the x-axis. So what I notice is since there's no gap between my region and the x-axis, I don't have to worry about that hole in the middle. I just have to worry about one radius. So in our case, our radius is going to be top minus bottom, just like it was before. My top is square root of x again, my bottom is 0, so my radius is the square root of x. So now I'm going to go ahead and find my volume. I know my formula is pi. I'm going to integrate from 0 to 4. I need to take my radius and square it. So there's my pi r squared. And then, of course, I have my dx. And now we just need to do the antiderivative. Well, I can simplify this a bit first to make it easier. Square root of x quantity squared is just x dx. So now I'm going to leave my pi out front. My antiderivative is x squared over 2 plus c. And evaluate from 0 to 4. So let's see, when I plug in 4, I have 4 squared is 16 divided by 2 is 8 plus c. And then I'm going to subtract, plugging in 0 just gives me 0 plus c. So my c's cancel, and I end up with 8 pi for my volume. Oops, sorry, cut that off there. All right, then the last piece here, similar to what we did above with the area, but now we're talking about the volume. Okay, it says the vertical line x equals k divides region R into 2 regions such that when these 2 regions are revolved about the x-axis, they generate solids with equal volumes. So find the value of k. So same idea here. I'm going to take my same formula here, except instead of integrating from 0 to 4, I'm just going to integrate from 0 to k. So I have pi times the integral from 0 to k of x dx equals, now if those two volumes, are going to be equal, I know it's just half of my volume here. So that's going to be equal to 4 pi. So the first thing I'm going to do is just cancel my pi's. Okay, now I can take my antiderivative, x squared over 2 plus c. I'm integrating from 0 to k. So I have k squared over 2 plus c minus 0 plus c. So I have k squared over 2 equal to 4. I'm just going to go over here. I'm going to multiply by 2, so I get k squared equals 8. And so then I know k is equal to, now technically it's positive or negative root 8, but since I'm in the first quadrant here, I know that has to be a positive square root of 8. So what that says is if I used this kind of formula here, integrated from 0 to root 8, and then I did another integral doing from root 8 to 4, I should get the same volumes. Okay, so that's it. You'll be working through a lot of different versions of these AP problems when we're back in class. Have a good one.